Thanks for reminding me.
Sure thing.
Okay, so that's problem 5.16. We opened up the probability distribution, and now we're going to open up the data set. So it's coming right there. So I want to be able to calculate the let's see. Got to remember how to do this. See, the basic formula is you just multiply x times p of x. So there's 11 products. You add them up. That's the mean. Okay? And then there's another formula for the standard deviation, which is more complicated. But let's see if I can remember how to do this one. Let me see if it's custom. Yeah, the values are in x, and the weights are in p of x.
I still can't see anything.
Oh, okay. You don't see it?
No, it's a blank screen.
Okay, let me see if I can share content again. Okay, it should open up right now. Do you see it?
Yep, no, I see it.
All right, so what I told it to do was I'll back it up. I'll show you again. Okay, there's the raw data. We just moved the data to StatCrunch. You go to Stat, Calculator, and you go Custom all the way at the bottom. It tells you the values are the values of the random variable, which is x. So I tell it that's x. The weights are the probabilities. They're weighted as probabilities. And I tell it compute. And there it is. You can see on the left is the mean, 5.077, and the standard deviation is 1.742. So the mean is the middle. So in the middle, we have 5.077. If I add twice the standard deviation, so plus 2s will be 5.077 plus 2 times 1.742. All right, so I'm going to use a calculator. I don't know if you can. I do have a calculator, but on the side, you can use a calculator. So what we have is 5.077, that's the mean, x bar, or mu is actually mu, plus twice sigma. So 2 times 1.742 is 8.56. And now I just hit my calculator, I hit second entry, and I move back over with my cursor. I change the plus to a minus. So now I have the mean 5.077 minus twice the standard deviation. That'll be 1.59. So the rule of thumb says that for 95% of the data, we expect to be between 1.59 and 8.56. So that includes all the numbers between 2 and 8. Because remember now, the random variable takes on whole numbers, 0, 1, 2, all the way through 10. So the only numbers that aren't included in this rule of thumb are 0 and 1 and 8, 9, and 10.
Which is the one you said that includes all whole numbers?
Well, if you did the calculation with me, we have a confidence interval 1.59 to 8.56 by the rule of thumb. The rule of thumb is you take from the middle, you move 2 standard deviations either side of the mean.
Right.
All right, so we came up with 1.59 to 8.56. So the only numbers that are included are 2 through 8. So everything else is unusual. So now I can go back and answer the questions, right? So let me go back to the problem. And the first question is, I'm going to close, well, wait till it pops up. So there it is. I'm going to close the probability distribution because I don't need it anymore. So done. It says use the range rule of thumb. Okay. To identify the values that are not significant. The maximum value in this range is 8 girls because it runs from 2 to 8. So that's the maximum. Wait a minute. I'm sorry. I'm going to use 8.56. That's what they wanted. They wanted
It says 1 decimal place, sir.
Oh, 1 decimal place? Okay, 8.6. Thank you. Appreciate that. I didn't read it. All right, so that's according to the rule. So then the minimum is 1.6. Check. Okay. So based on this result, is 1 girl in 10 births a significantly low number? Yes, because it's less than 1.6. So which one? It's either B or C. So it's B says above, C says below, so it's below the range. So that'll be the correct answer. Follow?
Yes.
All right, so there we go. So that's what that range means. It means it's the range rule of thumb, which means plus or minus 2 standard deviations either side of the mean. So for that probability distribution, that's how we calculate the mean and the standard deviation, because the formulas are too complicated. They're a waste of time.
Yeah. Without knowing how to use StatCrunch, I've had to been using the formulas. So I got plenty of scrap here filled up already.
Okay. So let's see. What's your next problem?
I'm looking for one that I got the very next one, 5.1.21. I have I got the mean correct, but the standard deviation I got incorrect.
Okay, so this one, see, it's a probability distribution. It doesn't say binomial. It doesn't say normal. It just says probability distribution. So we're going to do the same thing. I'm going to click on the icon. You see, there's the distribution. So it's a custom. So I say, I hit this icon and I copy the StatCrunch. So which you cannot see, so I will go ahead and open that up. And so we move the data to StatCrunch. There it is. Do you see it?
Yes.
So the random variable takes on the values 0 through 5. And there's the probabilities. Those are the probability densities. They're calling weights. So I want to calculate the mean and the standard deviation. I go to Stat, Calculator, Custom. I tell it that the values are the X values. The weights are the probabilities. I tell it compute. And there it tells me the mean is 1.47. The standard deviation is 1.052. So the first question was, I forgot what it was. I'm going to go back and get it so we can answer the first question. The first question was the mean. Okay. And then let's see. Okay, so the mean is 1.47. The standard deviation, sigma, was 1.052. And you see the calculator here. I can calculate particular values if they ask me for probabilities. I'm going to leave that open. I'm going to go back to the problem.
Wait, where did you see the calculator?
Right here, the bottom. I'm circling it. Let's say I wanted to know the probability of exactly 2. So I would put equals 2. And there it is, 0.291. You see it matches.
Mhm.
It matches the distribution, 2.291. You see that?
Got it.
All right, so that just validates that it's working. So now I go back to the problem. And I'll wait for it to come up. So it says 1 decimal place, so that will be 1.5. And then you said you had a problem with the standard deviation, 1 decimal place, that'll be 1.1, right? It was 1.05, so it rounds to 1.1. That's it. They don't want to know anything else. That was it. That's pretty straightforward.
You got that right?
Yeah. Oh, I'm sorry, I went too fast.
Okay. No. Oh, yeah, actually, your screen is a little bit lagged.
Oh, okay.
But mine does say correct answer is 1.0.
Well,
And
we
then
had
plus
different.
minus
We might have had
0.1.
different numbers. We have different numbers. See, if I open this up
All right.
again, I'm going to have different numbers. You see, it changes. It changes the probabilities. You see how they're changed now?
Okay. Okay.
Yeah, it's random. It's random numbers because if you work the same problem over, it'll change the numbers. I mean, they'll be valid. They'll be add up to 1, but they'll be a different distribution.
Mhm.
Okay.
Got it.
My standard deviation was 1.05, so it rounds to 1.1. Yours might have been slightly different.
Got it.
All right.
All right. And the last, let me see. So 5.2.28.
5.2.28. Okay, I gotta close this. I gotta
Is
go
question
back.
12.
Study plan. 5.2.28. It only gives me one section at a time, so I gotta go back and retrieve. There it is, with a T. And then I got to show it to you, make sure it's the right one. And based on a poll among adults who regret getting tattoos, is that the one?
Yes, sir.
All right, mine said, you see it?
Yes.
Mine says 19%. So that's the probability of a success. P equals 0.19. Assume that 10 adults, so N equals 10. So this is a binomial. I need NP and then I need X. I need the number of successes. So in problem A, it's X is 0. It says none. But for you to see that, what I do now is I have what I need. This time I go to question help, open stack crunch. You see what I did?
Uh-huh.
Okay, so now I got to open stack crunch so you can see it. Give me a
Are
second.
we allowed to open StackCrunch during the test?
Yeah. Where it says
Okay.
question help. You see where it says question help?
Yes.
That's where you can open stack crunch. Exactly.
Okay.
Yeah, I have it set up so that you can use it during the test. Otherwise, it's kind of silly. You do all the prep work and then you can't use it. So now in stack crunch, here it comes. Right there. You see it? So I'm going to say calculator binomial. You see that?
Not yet.
You see stack crunch?
No.
All right, I got to reload it, unfortunately. I closed it accidentally. Shucks, I got to go back and reopen it. There it is. So question help, stack crunch. I got all these extraneous windows open. Bear with me. All right, so, oh gosh. My computer went haywire here. Let me figure out what's going on. Oh, that's why. I have too many stat crunches open. That's why. All right. Let's see if it pops up. There, do you see it now?
Okay, now I see it.
So now I go to stat, calculator, binomial. You see that progression?
Yes.
I hit binomial, and I just leave it standard, and I want to change n. N is 10. No, I can leave n as 10. The probability of a success was 0.19, so 0.19. Compute. Now, the first probability was for x equals 0. So down here on the bottom, I just write x equals 0. You see what I'm doing?
Yes.
And then I hit compute. There's the probability, 0.1216. 0.1216. That's the probability that there'll be 0 successes. So now I go back to the problem. This is time consuming, but it's the only way to do it. So I go back to the problem. And here comes the problem, right? Okay, there's the problem. I hope you see it.
Yes, I do.
So 4 decimal places, 0.1216. I hit check answer, and it says good job. Okay, so now next part B, find the probability exactly 1. So now I want to go back to StatCrunch and just change x equals 1, because n is the same and p is the same. The probability doesn't change. The number of trials doesn't change. All it changes is we want to know what's the probability of exactly 1 success. So without having to go to show you what I did, I go back to StatCrunch and I just put x equals 1 and I hit compute and I get 0.2852. 0.2852, and so I come back to the problem, which you can see, and I put in 0.2852, check answer. So you see, I just go back and forth between the two screens and calculate the probabilities.
Got you. Can you just give me a moment? I'm gonna actually work mine out, see what I get here on my side. Because I had worked it out via, formulas and everything. I did
Okay,
get
I'm
the
going to hit
first two.
OK. I'm going to see what the next part for me is, but go ahead.
Okay. For the probability, I do 1, let's say so 25%. 1. You change the n and then the p and then the probability.
No, they stay the same. The only thing I changed was x equals 0 to x equals 1 at the bottom. You can't change n. That's set for the whole problem. There's 10 trials, 10 adults. That's 10 trials.
Okay,
The
wait. Let me see how
probability
many
stays
trials.
the same. 0.19 stays the same because it's a binomial. The probability doesn't change. And then
But my numbers are different. So let me see. Mine says that assume that 5 adults who regret getting tattoos are randomly selected.
all right, so x equals 5.
Okay, so where do we get the 10 from?
Okay, then n is 5.
Okay, so that is the n. So n is 5. N is 5.
And what's the probability that one of them that they say they're too young?
25% say that.
0.25. That's p is 0.25.
Got you. And then what do we do with x? X is the 1 now, right?
If
they ask just for 1.
Does it say exactly 1?
Yes, exactly
x equals 1.
Gotcha. Okay. 3955. Okay, that is what I got. Yep.
All right.
That is what I had got. Good.
Now look back.
Now
go ahead.
Yeah. So the probability that one of them is that the number of selected adults saying they were too young is 0 or 1. That's what I didn't understand.
Well, look at the screen. Part A
Yep.
is 0, part B is 1. What do you think? What should do I have to go back and do some more calculations, or do I have enough information right there in front of me?
Okay, so you input both of those separated by a comma?
No, I just add them together.
Okay, that one or the other one. Gotcha.
You just
Okay,
add them together. It's an or, so it's one plus the other plus the intersection. They don't intersect, so the intersection's empty. So you just add them. They're disjoint. You just add them together.
Okay. All right. Also, I'm
So
overtaking it.
so for me,
Gotcha.
it's 0.4068. Check answer. See, I just added them together because it's 0 or 1. Okay?
Okay, that sounds simple enough.
All right. I'm going to say okay. And part D, if we randomly select 10 adults, is 1 a significantly low number who say that they were too young to get tattoos? Well, remember, it's the range rule of thumb. If it's less than 5%, then that's true. But we already know that 1 is 0.2852, so that's not significantly low. So the answer is no, because the probability that, let's see, it says that exactly, actually 1 is greater than 5%. See, they're giving you the limit. The limit's 5%. So I look at part B and it says 0.2852. That's great, much greater than 5%, so it can't be significantly low. Oh, what did I do wrong here?
Do you have a stapler?
My father does.
I'm not sure what they're driving at here. This is when I get confused by the machine. If we randomly select 10 adults, is 1 a significantly low number who say they were too young to get tattoos? 1 a significant. Maybe this is maybe at most 1. We'll do it that way. Let's see what happens. Yeah, I just put exactly 1 instead of at most 1. They were looking at part C instead of part B. It's hard to read into some of these questions. I agree with you. I agree with you guys when you guys complain. But anyway, it's no, because the probability that at most 1. So at most 1 means 0 or 1. And obviously the probability in part C was 0.40, which is much greater than 0.05. So that's why it's a no. Okay?
Gotcha.
At least they gave us a second chance.
Yeah. I mean, I said we'll get that on the test.
Well, yeah, fortunately.
All right.
Anything else? I'm going to go ahead and close this in case you have another question.
Could we work out problem 13? The next one, 5.2.32.
5.2 point which?
5.2.32.
3.2. Okay. Let me see if I can go get that. Where the heck is it? Oh, there it is. Okay, it says assume that the hybridization experiments are conducted with peas. Is that the one?
Correct.
All right, so let me open it up for you. See what they need to do. I don't know if your numbers are going to be the same once again. That's because they're always changing numbers because of randomization. Okay, mine says assume that the hybridization experiments are conducted with peas having the property that for offspring there's a 75% probability. So that's P, 0.75. By the way, what's Q?
The very next number.
No,
It's simply
0.25.
the offspring.
P plus Q always equals 1. If P is the probability of a success, which is a green P, then 0.25 is the probability of a success of a not green. All right. Assume the
Gotcha.
offspring are
Okay.
randomly selected. So N is 30. Okay, so we have, it's a binomial. We have P and we have N. Find the mean and standard deviation. Now this one, this is actually, you don't really need the stat crunch for this, because for a binomial, the mean mu is NP. So it's 0.75 times 30, which is 22.5. How about that? And then sigma is the square root of NPQ. So it's the square root of 22.5 times 0.25. Obviously need a calculator to do that. And
Wait. I'm sorry. Could you repeat what you just said?
it's on the formula sheet. It's the square root of NPQ. That's why you got to know Q. So if I take second square root and I do 0.75 times 30 times 0.25, I get 2.3717. 2.3717. So I know the mean is 22.5. We're going to double check these. I'll show you how the calculator does it. Okay, and then the value 1 decimal place, that would be 2.37, so 2.4. Okay, so there's the mean and standard deviation for a binomial. All right.
Okay, so the value of the mean, the first one you did 0.75 times 30 times 0.25.
No, just NP. Don't you have the formula sheet? Did you download it?
No, I normally use the homework, where it shows you the formulas, and I have them. I mean, I have them written down, but I don't have a formula sheet. Do I get on Blackboard?
No, it's in. I'm going to bring it up for you. It's in. Let me see if I can find it real quick. Where is it? Gosh. Some of them I copied, some of them I didn't. I can't see. Hypothesis testings, formulas. Is that it? Let me see if this is it. Probably not. You know what? Let's see where. Actually, let's see. I'm going to share it now. Do you see it?
Yes.
This is from test number 1. By the way, there's the range rule of thumb.
Mm-hmm.
At the number 7, that's the
Right.
explanation for it. There it is.
So
Significantly
where
low.
can I download it?
Yeah, you can download it. They're on Blackboard. There's tons of formula sheets I put in Blackboard.
Oh yeah. That's what I asked. It was on Blackboard. Gotcha.
Yeah, it's all in Blackboard. Now this one doesn't have what I'm looking for, unfortunately. So
I did download all of the PowerPoints. I don't know if that was on a separate one.
Yeah, somewhere in there, there's a shortcut formula for the binomial, which is mu equals NP. So N is 30, P is 0.75. So that's how we got 22.5. See it?
Mu is that symbol right there, right?
Mu is the mean. Yeah,
Right.
that's mu. It's a
Right.
Greek lowercase m. It's pronounced mu. It looks like a U, but it's mu. Mu.
mu. Okay, so what you said mu was what? Mu was
NP.
NP. Okay.
And then sigma, right below it, you see value of sigma?
Right.
That's lowercase sigma. That's the standard deviation.
Standard deviation.
That's the square root of NPU. So you got 22.5. You multiply by 0.25 and take the square root. Rounded is 2.4. So that's the standard deviation. Now they want you to do the range rule of thumb. Well, you'll take the middle is 22.5 and you will add, let's see, they want the low, so you would subtract 4.8. So 22.5 minus 4.8, 17.7. So that's the low, 17.7. Check answer. Okay. The high would be 22.5 plus 4.8. So I just add now instead of subtracting. I get 27.3. So that's the range for usuals. That's what we expect 95% of the time to have results between 17.7 and 27.3 on average. That's our confidence interval. You see that?
Yes, gotcha.
That's what they mean, range rule of thumb. You just add or subtract 2 standard deviations from the center. That's why we need the parameters. We need the center and the spread. The center is the mean, the spread is the standard deviation, and we use 2 of them for our typical confidence interval. That's essentially a 95% confidence interval. Okay? I'm going to go ahead and hit OK. Now they want one more question here. Is a result of 10 P's with green pods a result that is significantly low? What would you answer?
As a result of 10 P's with green pods, a result that is significantly low. I would say no.
Well, it's less than 17.7. I mean, that's the low end. We just read what B says. That's 17.7 is the low. If you got 10, you're way below 17.7. So the answer is yes.
Oh, all right.
It is significantly low because 10 P pods is less than 17.7. That's the low end, 17.7. That's what we're talking about, a confidence interval. The confidence interval is your usual values. If you're in the confidence interval, you're usual. If you're not, you're not usual. 10 is not usual. It's significantly low. If you're on the low end, you're significantly low. If you're on the high end, you're significantly high. Those are called tails. We ended up in the tail. 10 would put us in the tail. 17.7, 27.3 is the interval. That's the body. That's the confidence interval. That's where we want to be 95% of the time. That's where we expect to be, I should say. Okay? All right. I'm going to hit next question. I think that one's done. Yeah, it's done. All right. What I'll try to see, if you go to Blackboard, you can download and print off, let's see, it'll be, let's see if I could tell you which one it is. No, I better not. I might screw it up. I better let it go. But if you go, I think all the formula sheets are in week 2. Open it up, you'll have, and they're listed, either by category or chapter, but there's a definite descriptor for what the formulas refer to. Okay?
Okay, I see it. All right, yep, I see it.
Yeah, just I would print those out and have them handy so you can use those for as you go along, because when they ask you questions, they're going to assume you know how to do that. Now, I guess I closed it out, but I can go back. Let me go back. I can go back to that problem. Now, we could actually calculate this. Watch, I'll show you. I'm going to do stat crunch. So let's see, for me it was n equals 30 and p equals 0.75. So let me open up StatCrunch to show you what I mean. So let's see, where is it? There it is. So I go to StatCrunch. I'll wait for it to come up in. I'm locked up. God darn it. Shucks, it's not responding. I'm kind of locked up. Okay, what I can do here? Let's see. This happens. It's technology. Gosh darn it. Well, I don't want to end the task. Yeah, I'm locked up, Alexander. Unfortunately, I'm going to have to log out and log back in. So
Okay.
I think did I answer all your questions, or do you want me to come back?
Yeah, that was all the questions I had. At least for the homework that I've done up to now, I have the remainder of that homework to finish. I wasn't able to finish it on time. But obviously, again, I need to be learning how to use this StatCrunch a little better, be a little more proficient with it. But I believe so, and I'll use the formula sheets if I have any questions, and I'll try. Is there anything else on StatCrunch that you could? So you still there? All right, Veronica, you there? Do you know how to use StatCrunch pretty well?
I mean, yeah, next to some of my problems, because I'm already on homework 7, so I could kind of give you a heads up on certain things with the stat crunch. And then once you get a hang of it, it's actually kind of simple, but I write it down next to the questions that I do. That way, when I go to do the test, I know that by those certain questions, that's the type of stat crunch that I need to use.
Okay, I'm back.
Where did you learn?
Because there's
Okay.
2 different sections that you use in stat crunch for your assignments.
Right. Which are what? The calculators under stat?
Yes, but see, usually beside the formula, there's a tiny little box. And that's the box that you use for StatCrunch. Don't go into the up in the right-hand corner and use StatCrunch.
Right.
You hit that, and then you usually, the majority of the time from what I've learned from Dr. K is you go to where it says Stat, and then you'll either use Summary or you'll wind up using, I believe it's, it starts with the R, the regression. So it depends on what questions that you're on which one you would use to help it.
Okay.
And I'd have to look, I have to see it while I'm doing it.
Speaking of which, I'm back. Does anybody have a particular question? Maybe we can answer it.
Yes, I just started homework 7,
Okay.
and I feel like it's really easy and I'm just not catching something. But I need you to tell me. I don't understand the whole table thing. Like, I've tried to do it the way they told me to, but I don't understand what they're seeing on the table that I'm not. Or if you are supposed to use StatCrunch.
Which problem is it?
6.1.13.
All right, so it's the normal, right?
Yeah, it's finding the indicated z-score. The standard normal distribution with mean 0 and standard deviation 1.
Yeah. 6.1.13 is right there. Okay. All right, so I might have different numbers, but I'll open it up and show you what it looks like.
If I'm correct, which this one isn't shaded, but if it's shaded to the right, then you -1, and if it's shaded to the left, then you don't have to -1.
Yeah, but you can use StatCrunch for this, or you can use the TI-83 actually.
All right. Well, you can show me how to use StatCrunch.
All right, so I'm going to write down, you see, to the left of the, we want the Z value that has 0.8770 to the left.
I don't see your page.
You don't set it up?
Mm-mm.
Oh, I threw it up there. Let me try it again. Sometimes it's just bulk set. Okay, it should be coming up right. Now.
Yep, now I see it.
So it has 0.8770 to the left. It's not shaded, but that's the implication.
Right.
So to the right is the complement, would be 1.122, 0.1230. Because they have to add up, the right tail would be the complement. We have to add up to 1.
Okay, so
But
you're adding.
typically, we always read from the left for normal probability distribution. You read from minus infinity to plus infinity. Technically, this is an infinite z-axis. But in reality, once you get past 3 or 4 standard deviations, the probability goes to real small values. Okay? So I'm going to open up Question Help StatCrunch. Now I got to open that up for you to show you what I'm doing. And I hope you can see this coming up right now. You see it?
Yep.
All right, so I go to Stat, Calculator, Normal. Where is it? Normal. See down here?
Yep.
See it, and see the icon?
Yes.
It looks just like the one we had in the problem.
Okay.
So it's standard normal. So look down here. It says mean 0, standard deviation 1. So all I do is now one of the problems is that it has X right here. Now since it's mean 0, standard deviation 1, that technically is a Z, but it's permanently X. So don't let that throw you. So in here is the probability. So this is where I put in my number, 0.8770. See, because it says X less than, well, it'd be Z less than, I'm looking for the number that's right here, that's blank. So I put the probability in, and they give me the answer is 1.16. And you see the icon, the standard normal distribution is just like the one I had, only instead of being blank, it's red.
Okay.
And so to the left is 0.8770. So the number on the z-axis is 1.16.
Okay.
So I go back to the problem. And should be coming up right there. You see
Yep.
it?
Yep.
So there's 2 decimal places. So 1.16.
Okay.
Check answer. Now, by the way, I'm expecting a positive number because I have more than 50%. 50% would be 0 because that's the median. That's the mean, and that's the thing about the normal distribution. The mean, the median, and the mode are all the same number. They're in the middle. It's 0 on the standard. So I expect 50% to the left. So if I have a probability greater than 50%, I expect Z to be a positive number.
Right. That makes sense.
Okay, good. Just throwing in these little tidbits so you can. All right. So that was that one.
Yes, that one that you're on right now was the next one that I was going to ask you about, the 6.1.14T.
All
So
right, do you have
the same thing, right?
Do you have a TI-83?
I do. I have a TI-84, I think.
Okay, so here's what you do. Here's what you do. What you want is inverse norm. So the way you do that, turn it on,
Right?
hit second vars.
Like the second key, you mean?
Yeah, second VARS. It should say distribution above VARS as a second function. You see it?
Oh man. I think it's just because I have to look at it while I'm trying to do something. I see the second, but I don't see
VARS is in the third row on mine anyway.
VRS.
VARS, VARS. Of course, you have said you have an 84.
Yeah.
Oh boy.
All right. Well, I have a stat plot. It says y equals.
No, you don't want stat plot.
Okay. I have a table set
VARS
format.
is right next to, on mine, it's right next to the clear button. It's right, it's in the second column from the right below the arrows, the arrow keys.
Yeah, I don't have that. Lame. Oh, I see it. I see it. I see it. I see it.
Now,
Okay.
what's written above it? Is it DISTR?
Yes.
All right, so hit second and hit that key.
Okay.
Now, it should say normal PDF, normal CDF, and then inverse norm.
Yes.
So hit number 3 and plug in the value, 0.2358. 0.2358, enter.
0.2358. Oh,
Yes?
hold on.
Did you get negative 0.72?
Sure. Then it goes to the mean, the one, and a paste. I got 0.2358.
And put parentheses. Just put a
Yeah.
right parentheses.
And then it says negative 0.7198.
That's it. That's the answer. -72. That's the answer. We expect a negative number because to the left is 0. They showed us 0, so we expect a negative number. We're 0.72 standard deviations to the left of the mean, which is 0. That's the answer. We asked it for. See, they gave us the probability. We wanted the normal. We wanted the number. So they gave us the number. When I hit check answer, it says fantastic.
All right, cool.
Now this would have been the same thing I would have done in StatCrunch. It's just if you got a calculator, it's a little quicker sometimes.
Yeah, I just noticed that. Cool. And so I'll be using this formula throughout most of this.
Well, that's for inverse norm. For if you want to find probabilities, then you would use the other one. Let's work it backwards. Let's say we know the z. We want to find the probability of 0.2358. So for that one, I would hit second vars, okay,
Right.
and then hit number 2, normal CDF.
Okay.
Now I need a left boundary. Technically, it's negative infinity, but I can't put an infinity in here. So I just
Yeah.
put -10, comma, and I put -0.72 because that's the number we know is true.
Comma.
-0.72.
There's a comma?
Commas above 7.
Ah. -10, comma 7.2.
Negative.
Yeah, -10, comma
-0.72.
-0.72.
See, what we're doing is we're telling it what's the area between. We're asking it for the blue area. We already know the answer. Let's see if it's correct. When you hit enter, you should get 0.2358.
Well, it's asking me for lower and upper.
Just put a parentheses around because just put a parentheses after the 0.72.
Oh, okay. Parentheses. No, it still wants me to.
Did you hit enter?
Yeah. Still wants me to do something with upper. It says lower, upper, mean, standard deviation, paste.
Yeah, well, we gave it the lower and the upper. The mean and the standard deviation are 0 and 1 because if you
Oh.
don't tell it, it automatically assumes that it's 0
So
and 1.
I need to put the negative 72 in the upper.
Yeah.
Okay, that's why I need to put negative 10 in the lower, negative 0.72.
Yep.
Enter, 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 enter.
If they ask you for the mean and the standard deviation, it's 0 and 1.
Yeah, it has that in there. It says that there's an error. I'll have to try to do it again in a second. But I get what you're saying.
But I generated 0.2358. I generated the probability. You can go either direction. You can generate probabilities, or you can generate z-values that would give you those probabilities.
Okay.
And then the reason they have mean and standard deviation, you can also use this for x distributions, x normal distributions, because the assumption, if I don't put 0, 1 after my upper and lower and upper, it automatically assumes those. But if I have a different distribution, like let's say the mean is 10 and the standard deviation is 5, then I put those numbers in and it gives me the results for that normal curve.
Okay, so where do I need to put the parentheses?
Well, for the 83, you just put the lower upper and just put the right parentheses after the upper. And then you just don't put in the mean and standard deviation because they're assumed to be 0, 1.
Okay, so I don't put a left parenthesis. I just put a right parenthesis after each one.
No. See, on mine, it's normal CDF, left parentheses, negative 10, comma, negative 0.72, right parentheses. And then I hit enter.
Okay.
I don't know if I can show you my calculator.
I'll have to go check one out. See, on mine, it says upper, and then below it says lower, and then it has the sign for mean, and then it has the sign for standard deviation, and then it says paste.
So it's a little different.
Yeah, so I'll just have to figure out the correct way of typing in. I'm sure it's not that far off. It's just something that I'm doing wrong.
Yeah.
All right, let me try some of these questions out.
You tend to catch on pretty quick.
I'm trying to. It makes sense. Like, I like statistics. It's a little tricky. I can see how your mind goes a million miles an hour because you have to think this all the time.
Okay, basically we're getting ready to set up the testing and confidence intervals, and we've been doing that all. We did the regression. When we were in the middle, that was the confidence interval, and when we ended up in the tails, that was significant. And that's why they're asking you for these range rule of thumbs, because if you're between plus or minus 2 standard deviations, that's a 95% confidence interval. And if you're in the middle, then you're okay. But if you end up in the tails, then you're significantly low or significantly high. And that's basically why we need a center of the central tendency for the mean, and we need a way to spread from there toward either end, which is why we need the standard deviation.
Got it.
So that's what's coming up in the chapters 7 and 8 with the confidence intervals and the hypothesis testing. But you got to be able to work the probability distributions to understand how, where the data is coming from and what it looks like and what you can do with it. Okay.
All right. Thank you, Dr. K. I'll talk to you later.
I'm glad that you're on. Good to see you, or good to hear you. Okay.
Be careful out there.
Bye.